Combination of errors. Objective: to measure error in a physical quantity that depends on multiple variables. If an experiment involves measurement of multiple physical variables, we should know how the errors in all measurements combine. For example, density is obtained by dividing mass by the volume of the substance. If we have errors in the measurement of mass and volume, we can determine what error will be there in the density of the substance. Let us learn how errors combine in various mathematical operations. Error of a sum or difference. Suppose two physical quantities, A and B, have measured values A plus or minus delta A and B plus or minus delta B, respectively, where delta A and delta B are their absolute errors. We wish to find the error delta Z in the sum Z, which is equal to A plus B. We have by addition Z plus or minus delta Z is equal to A plus or minus delta A plus B plus or minus delta B. The maximum possible error in Z is delta Z, that is equal to delta A plus delta B. For the difference, Z is equal to A minus B. We have Z plus or minus delta Z is equal to A plus or minus delta A minus B plus or minus delta B is equal to A minus B plus or minus delta A plus or minus delta B. Thus, the maximum error in the difference, delta Z, is equal to delta A plus delta B. Hence, when two quantities are either added or subtracted, the absolute error in the result is the sum of the absolute errors in their individual quantities. For example, temperature of two bodies measured by a thermometer are T1 equals to 20 plus or minus 0.5 degrees centigrade and T2 equals to 50 plus or minus 0.5 degrees centigrade. Temperature difference and the error therein is T dash equals to T2 minus T1 that is, T dash is equal to 30 plus or minus 1 degree centigrade. Error of a product or a quotient. Suppose Z is equal to AB and the measured values of A and B are A plus or minus delta A and B plus or minus delta B. Then Z plus or minus delta Z is equal to A plus or minus delta A into B plus or minus delta B. That is equal to AB plus or minus B delta A plus or minus A delta B plus or minus delta A delta B. Dividing LHS by Z and RHS by AB, we have 1 plus or minus delta Z by Z is equal to 1 plus or minus delta A by A plus or minus delta B by B plus or minus delta A by A into delta B by B. Since delta A and delta B are small, we shall ignore their product. hence the maximum relative error. Delta Z by Z is delta A by A plus delta B by B. The same rule is valid for the error of a quotient as well. If Z is equal to A by B, relative error delta Z by Z is equal to the summation of relative errors delta A by A plus delta B by B. Hence the rule, when two quantities are multiplied or divided, the relative error in the result is the sum of the relative errors in the multipliers. Error in case of a measured quantity raised to a power. Suppose Z is equal to A square. Then delta Z by Z is equal to delta A by A plus delta A by A equal to 2 delta A by A. Hence, the relative error in A square is 2 times the error in A. In general, if Z is equal to A power P into B power Q by C power R, then delta Z by Z is equal to P into delta A by A plus Q into delta B by B plus R into delta C by C. Hence the rule, the relative error in a physical quantity raised to the power k is k times the relative error in the individual quantity. Summary. When two quantities are either added or subtracted, the absolute error in the result is the sum of the absolute errors in the individual quantities. When two quantities are multiplied or divided, the relative error in the result is the sum of the relative errors in the multipliers. Relative error in a physical quantity raised to the power k is k times the relative error of the individual quantity.